Today we're going to take a look at the ambiguous case of the law of sines. Now you already saw some example problems where we solved triangles using the law of sines, and the information given to us was either in the form of angle, angle, side, or angle, side, angle. Now we can also use the law of sines if we are given side, side angle, but this is the ambiguous case. And in the ambiguous case, with side, side angle, we're either going to get 0, 1, or 2 possible triangles. That's not the case with angle, angle, side, or angle, side, angle. Here we had only one solution. So how do you know if you're going to have 0, 1, or 2 triangles? So let's say I tell you that I've got a triangle that has measurements A, 15, B, 25, and angle A is 85 degrees. Now notice when we set up our triangle that we've got 2 sides and an angle. Side, side, angle. Now we can use the law of sines to solve for angle B. We have angle A, side A. We have side B, so we can solve for angle B. So we'll have sine of 85 over 15 equals sine of B over 25. Solving for B, we'll cross multiply. Divide both sides by 15. And I'm going to put this in my calculator, and I get that sine B is equal to approximately 1.660. Now what you should notice here is that we're saying that the sine of an angle is equal to a number that is larger than 1, which is not good, because if you remember, the range of sine is from -1 to 1. So this is undefined here. There's no angle B such that the sine of B is equal to a number over 1. And if you tried to use the inverse sign on your calculator, it would have given you an error message. So this is a case where we have no such triangle. So there's no solution here, meaning that we would never be able to construct a triangle that has an angle of 85 degrees and then the adjacent sides being 25 and 15. Okay, we're going to skip over one solution and go to 2 solutions. And let's say that we're given that A is 12, B is 31, and A is 20.5 degrees. Again, we've got side, side, angle, so we are looking at the ambiguous case. We can again use the law of sines to try to find angle B. So sine B over 31 equals sine of 20.5 over 12. We'll cross multiply. Divide. So sine B equals 31 sine of 20.5 degrees over 12. I'm going to use my calculator to get a value here. And I get that sine B is equal to approximately this number, 9047, which is less than 1, so that is in the range of sine. And if we use our inverse, we end up with approximately 64.8 degrees. Now you remember that sine is positive in the first and second quadrants. So what that means is that there's another angle in the second quadrant that has a sine of 0.9047. And its reference angle would be 64.8 degrees. So in order to find that angle, we would subtract 64.8 from 180. So there's another possibility for B, and that would be 180 minus 64.8, and that gives us 115.2 degrees. Now we can't within the same problem say that B is equal to 64.8 and also equal to 150.2 degrees. So I'm going to add a little subscript, and I'm going to say that B2 is equal to 115.2. So this means that we can create two triangles, one that has an angle of 64.8, and we can create another triangle that also has 20.5 degrees, a measure of 31, a measure in 12, except this angle would be 115.2 degrees. So two completely different triangles with the same angle, side, and side measures. Okay, now one solution. Let's say that we are given that A is 22, B is 12, and A is 42 degrees. Again, we notice that this is side-side angle, so it's the ambiguous case. We use our law of sines. Sine 42 degrees over 22 equals sine B over 12, cross multiply. We're going to divide both sides by 22, and we get sine B equals 12 sine 42 over 22. I'm going to put that in my calculator. And we're going to get something around 0.365. Now, solving for B, we'll get about 21.4 degrees. So we definitely have one solution where this angle is 21.4 degrees. But let's look for a second triangle. ABC, 22, 12, and 42 degrees. And we find that other angle by looking for the supplement. So we're going to say B2 is 180 minus 21.4. We get that this is 158.6 degrees. So this would be 158.6 degrees, except if you look at the given angle, we've got 158.6 and we were given 42 degrees. The sum of those two angles, that is 42 plus 158.6, is greater than 180, which is not good because we know that the sum of the measures of the angles of a triangle must be equal to 180. So this triangle does not exist, meaning that we have only one solution. And here is our summary. The ambiguous case is a special case of the law of sines. It happens when you are given side-side angle. And what you do is you use the law of sines to solve for an angle. And then you've got three cases. You have no solution if when solving for the angle you find that that angle is undefined. You'll have two solutions if you find that angle and then calculate that angle's supplement. And then you have only one solution if that supplement means that the measures of the angles of your triangle is greater than 180 degrees.